We're going to add to our knowledge about residuals, residual plots, and influential points. So let's go ahead and jump in and get started. A residual deals with least squares regression lines. This is a measure of error. In other words, an LSRL predicted a y value. The actual y value was different. How far off were we? How close we get? Right. That number, that measure, we call a residual. If we add up the residuals from an LSRL, we always should get 0. This kind of goes back to calculating standard deviation. We have to square it when we're doing standard deviation in order not to get 0 when we sum it up. We calculate error as observed minus expected. What did I see versus what did I expect? Expected meaning predicted value. So you'll see the definition of y minus y hat. Y hat again is the predicted, or what did I expect to see when I plugged in the x or evaluated at x. Okay, residual plot is a scatter plot based of the x lists and residuals, which we'll create in the calculator here in a moment. We can technically we can do it against other things, and we'll kind of explore that here in a moment with an actual problem. But a residual is, finally, we're able to use the word linear. A residual plot is how we finally get to say the word linear is appropriate or not. So we talked way back about correlation coefficient about R. R measured the association of two variables. Now we get to mention the word linear association, whether or not data happens to be linear associated. And this is going to be kind of a little backwards here until we get kind of used to what we're trying to do with that. When we look at a residual plot, we want to look for no pattern whatsoever. If we happen to see a pattern, that means there's another model out there. So you kind of think about it for a second. A residual plot is a measure of error. How far off was I from predicted? If I saw a pattern in my error, I could predict my error better. I should go do that. Residual plot being a random scatter of points means that I've done the best job I can. I've isolated out as much of the error as possible, and now the error is just completely random. There's some above, there's some below. It's all over the place. That's really what we're looking for. So in this first graph, this is what's called a good residual plot. This is a linear residual plot. I jokingly like to say that it looks like a shotgun blast. It just looks like someone just shot up the wall. There's no clear pattern going on. However, in this other graph, you can see that there is some predictability. It looks a little quadratic to me. And that means that the model I currently have is not the best model, and I could do a better job. So I should stop now and go find it. Anyway, so we would say this is not a linear model. Okay, so we're going to take the calculator out, and I'm going to show you exactly how one does this residual plot. What are the steps on that? So let's go ahead and do that. We're going to enter the ages into list 1 and the range of motion into list 2. Let me kind of get to that point, and then I'll restart the video. Okay, so I've gone in and inputted the data into list 1 and list 2. Let me kind of back up a second. It's kind of nice to know what it is we're looking at. So they went out and collected data about post-surgery remediation, post-surgery results. So you dislocate, let's see, your knee, or there's some sort of knee joint problem, and after the surgery they take your leg and they yank it up and they measure how far can they move it. And what they've done is they've tracked the data on that particular range of motion. Okay, anyways, going back to the statistical part now that we got the feeling part out of the way. All right, so we are going to start by calculating the LSRL. And let's see, so go to 4, list 1, list 2. And yeah, I want to store the regression equation, so I'll go to vars, go to yvars, and then put y1 in for that regression equation. Hit calculate. Okay, and then I hit enter. Now, when we did the LSRL regression, we actually generated another set, another list. Let me kind of go to the list screen and show you. When we did that, when we had it calculate the LSRL, it actually added a 7th list, the residual list. Residual list is a measure of the errors. So the calculator went into the regression line and it said, all right, at 35 I predict 154, or at 35 I have a prediction. How far off was it? Matter of fact, let's go look at that. Let me go to yvars. Okay, so I want to predict 35, and I got 138. So I predicted 138, but in reality it was 154. So the residual for that particular value, residual is observed minus expected. So I observed 154. I got the 138. So the residual happens to be 15.9 for that first one. Okay. Now, great that we have that. Let's talk about a residual plot then. So residual plots are x comma the resids. So when I go to stat plot, make sure it's turned on. Looks like a scatter plot's turned on, so that's good. And got highlighted, so it's a bunch of that first graph there. Good. List 1 is fine for that, but instead of list 2, I want to switch this to the resids that it just calculated, the residuals. So easiest way to get there is to go to second list and then just link up the resid to that. And then let's hit, let's see, zoom, stat. Let's see what happens. Okay, so we get that nice smattering of points. And, ooh, I have an old line that crept in there. Oh, from an earlier problem I was doing. Okay. Let me go delete that out. I have a Y2 in there. Let me go back to the graph. Okay, so now that line's not going to show up. So that's our residual plots, is x comma resid. Looks like that. Since we don't see a pattern in the points, then we can now say that there is a linear relationship of some type between age and range of motion. Okay? In other words, I don't have permission to say linear unless I've done a residual plot. All right, we're going to change the question. Let's plot the residuals against y hats, the predicted y values. So we need to go find those. So let me get my calculator back here. Okay, so if I go back to stat edit, let's think about what do we have so far. We have the x's and we have the observed, but I don't have predicted. So I'm going to go up to L3, and L3 I'm going to tell the calculator to give me the numbers that are predicted here. So that would be the y1 of L1. If that's not confusing, I don't know what is. Okay, so we're going to hit vars. We're going to get y1, so the equation that we told it to remember. And I want it to take all the numbers in L1 and stick it inside the regression line and give me a number out. So I'm going to do y1 and then parentheses L1. Let me try that again. L1. Okay. And then when I hit enter, it should give me a list of all of the predicted values. Those are all the predicted y hats. And then again, just so we understand what this is, if I take observed minus predicted, so if I do L2 minus L3, that would be my residuals. Okay. All right. So what are we graphing this? We're plotting the residuals against the y hats. Okay. So that means I want to go back to stat plot, and I want to change here whether it's L1 and residual. I want to change that to say residual and y hats. Okay, so I'm going to highlight where L1 is, and I'm just going to switch that to L3, which is where I stuck the predicted, the y hats. Okay, so then I'm going to go zoom stat, and I get pretty much the same graph as the original one. Okay, so putting them side by side. Typically, we'll do residual plots as x comma resid, but as stated earlier in the PowerPoint, there are other residual plots that also have some sort of meaning for us.